Welcome to today's webinar. We are going to get right into it because we have a lot to cover, and we have a lot of software professionals here on this webinar. I just glanced at the list, and we're excited at the large number who've tuned in for this particular topic. After a little over 20 years of agile software development, you might ask, rightfully so, why do so few leaders know how to use it effectively? And why do 50% of software projects still fail? And by fail, I mean the people who funded it, they kind of wish they hadn't. So far over budget, so far past the schedule, and the software doesn't exactly meet the original expectations. If they had it to do all over again, they would have done it very, very differently. It's failure. The key lies in understanding that practices and discipline differ from processes or ceremonies. And in a lot of the agile literature and training, a lot of the focus is on the ceremonies. Um, but we want you to master the proper implementation of agile leadership in your software teams, and in the software teams that you're overseeing, whether they're internal or whether you contracted, with one of our competitors to deliver a project. So we're going to go over some of the practices that really matter. We're going to talk a little bit about planning and how you should think about the budgeting and the estimates and time management, and going to share some tools to allow you to equip your teams properly with effective skills and in the right direction, and ultimately, establish a good measurement of progress. And so our hope is that you transform your approach to agile leadership and become more effective and succeed in your software projects. Now, um, given what I've already said, half of software projects still considered failures. ClearMeasure is a software architecture and engineering firm. And for those with projects that are too important to fail, we partner with software leaders and companies doing those projects to transform your software delivery. So our proven expertise establishes high quality first, then achieves rock solid software stability and accelerates time to market and speed of development so that you can rapidly deliver innovation, what you're trying to deliver. A little bit about me personally. I live in the Austin, Texas area, and I love amateur off-road dirt bike racing. I actually have a dirt bike race no, Saturday, and it's about once a month. Very amateur, cross country through the woods. My wheels kind of stay pretty close to the ground, and some of my kids have participated in that. So that's kind of my hobby, uh, and doing some ranching also outside of Austin. Before we get into it, I do have a free offer for any of your teams or any of your team leads or developers where it might be useful. My latest book, .NET DevOps for Azure. If you just send me an email, I've got an agreement with the publisher. I can kind of send an individual electronic copy to you free of charge. So just send me an email for that. And of course, you can buy print books, anywhere those books are sold, and you can find all of the other books and content on clearmeasure.com. All right. Now, I want to tell you where we're coming from. So, on our side at ClearMeasure, with decades of experience delivering mission critical software projects, we kind of know what it takes to predictably make a software project a success. But with so many teams that are still making rookie mistakes, and sadly, so many of our competitors signing up to deliver those software projects to clients and then making those same rookie mistakes, which, by the way, then the project overruns the budget, it doesn't meet the desired schedule, and it doesn't work the way it was supposed to. Our methodology, we simply call it the Clear Measure Way. It allows for the effective oversight and leadership of a software project, regardless of who's delivering it, whether it be us or one of our competitors or one of your teams internally in your company. And so we hope you find it useful, and you'll see just a small part of it today throughout this content. But today we are focusing on agile leadership. And most of you who are listening today are in software oversight, software executives, software managers, and I think we have also a grouping of CEOs of purely software companies. So that's the audience we're focused on today. So if you're attending, listening, this is a developer, then hey, I hope you listen and learn something, and maybe you'll move into software leadership one day as well. Okay. The Agile Manifesto, probably just by you being here, you understand what that is, and what you're seeing on the screen looks very, very familiar to you. agilemanifesto.org, the original website. Over 2 decades ago, the concept of Agile was born, and the Agile Manifesto was published, and it ushered in a really transformative era in the software development landscape. And it really emerged as a reaction in the 1990s, to the high failure rates of traditional software development processes, which were very high batch sizes. And I'll come back to that. The success of projects was kind of a rarity, and it was often plagued by those cost overruns. And what was the problem? Of course, everybody calls it, waterfall, but what was the problem was very, very large batch sizes of activities, where uh, you would think about a set of requirements, a set of software features, and documents for every one of those software features was developed painstakingly. And then that entire list of features, maybe we added some wireframes and did some user experience design on it. And then that entire set of features moved into some technical design phase, where we thought about software patterns and libraries and how we would implement things, and maybe draw some UML diagrams, some way, make a lot of those decisions. The entire batch, no code is still written, months in, and no code is still being written. And then we would go into test plan design, where we would determine how we were going to test all of these features that didn't exist yet, the entire list. And then we move into uh, coding, where the code for all of those features was written. And of course, the assumption was that all of the previous decisions for all of the features in that big old list, the assumption is that we were right about all of those decisions, and it didn't have any kind of feedback cycle. And so um, when the code was written, all of the code was written, and then it would be a while before any kind of runnable build of the software could be deployed to any kind of environment for testing. And then only once outside the team testing happened did the feedback cycles kind of start. So invariably, those waterfall projects started in that fashion, and then they ended by necessity in an agile fashion, with short feedback loops, but high stress because the project's already gone off the rails and it's already taking too long. And all of these assumptions that were false are coming back to roost. So the Agile Manifesto, it came as a response to to that prevailing project management style, and it basically took all of those activities and shrunk the batch size, shrunk it, and shrunk it, and shrunk it, and shrunk it. And with Scrum, well, Scrum really emerged as a guiding light. It kind of took the project management side of extreme programming, and it introduced, along with extreme programming, 2 week iterations. Extreme programming called the iteration, Scrum called it sprint. They introduced shorter development cycles through those, 2 week, and originally Scrum called it 1 month sprint, but came back to 2 weeks. And the shift, it really solidified it and promoted incremental progress, or the habit in the software industry of incremental progress and adaptability. And then leaders of teams using Agile could guide their teams to quickly respond to changing requirements and user needs. And we talk about changing requirements, but really is, we're making assumptions and we're making hypotheses, and then we're actually learning we're wrong. So it's not like our business customers are just changing their minds all the time. They're making the best decision as they can, but then as the project progresses and they see more, they realize that they're actually wrong. So they're not intending to change requirements. They're kind of getting it right at the same time. So we're shrinking the batch size. Instead of having this massive long feature list and doing one activity in the software development lifecycle, and moving that big batch size along, we're shrinking it down to maybe a set of features that'll fit in a 2 week iteration or sprint, and then doing all those activities, doing the conceptual business objective requirements, the user experience design, the technical design, the test design, the coding, the team level testing, the product management level testing, the stabilizing and deployment out to the customer in a 2 week sprint. And I'm not going to talk about the different ways that people have, like, implemented some of it and not some of it. That's not really the point here. But the point is that over the last 20 plus years, the industry has adopted a smaller and smaller and smaller batch size by which to deploy, by which to use the software development lifecycle. And um, teams have also learned from the lean manufacturing movement and adopted that into software development. And so overall, of course, throughout the industry, um, Agile's kind of evolved and incorporated those principles. Lean manufacturing started it, and uh, we also kind of adopted the concept of Kanban style boards for transparent work tracking. One of the most profound changes introduced by Agile uh, was driving the batch size down to a size of one, and adopting a Kanban style board allowed applying all of the activities in the software development lifecycle to a single feature, and then flowing one feature, two feature, three feature across that Kanban board visually, and into production into our customers' hands. So teams who have um, been the most mature on implementing the Agile mindset, implementing the Agile manifesto, the original principles, have gone beyond Scrum's concept of a 1 month or 2 week sprint or even a 1 week iteration, and have basically graduated beyond iterations of the notion of a batch of features, and have just worked on features one at a time. And if the business has a weekly cadence, and there's deployments to the actual customers on Wednesdays and Fridays, well, you know what, that whoever's doing product management for the business, that's perfectly fine. But the software engineering group has driven down the batch size to one, and they're ready to deploy anytime product management or customer support wants a deployment. And some companies deploy every day, multiple times a day, but deploy. Most companies who have adopted Agile don't deploy every single day. The business just doesn't work that way, or it's not just quite a fit. It's whenever a customer event happens, and product management can decide. But either way, the frequency of deployment is no longer dictated by the software organization. It's decided by product management or customer support. Okay. The first concept in effective Agile leadership that I want to stress is quality. And there are high stakes for letting defects escape out to your customer. There's orders of magnitude difference of cost between finding and fixing a defect when a developer is working on the code for a feature versus it leaking out to the team versus it leaking out beyond the software team to product management, and then finally being deployed to a customer. And there's plenty of research on this, and so we don't want to let defects happen. We want to prevent almost all of them, and there's practices for doing that. Because even fixing defects is hazardous. 9% of defect fixes introduce a new defect. So the first priority, and of course, I think a lot of the engineering practices originally defined in extreme programming were aimed at increasing quality. And that's been a theme of research, and even learning from lean manufacturing. Now, Edwards Deming passed away in 1993, but he was a leader in the quality revolution after World War II, and he published hundreds of papers and articles and books. And one of his ideas is the Deming cycle, or Deming chain reaction, and that's used in quality control. And then, of course, that same idea has made its way into software. But the notion is you improve quality, and lots of good things happen. Less rework, fewer mistakes, fewer delays and snags. And then, because you're spending less time on rework and bad things that are happening, well, your overall productivity improves. Well, now the productivity improves and things go better with the software project. You capture the market with either better quality or a lower price, and the business does better. You stay in business. Well, then the business prospers and grows and provides more jobs and more jobs. And then you start the cycle over again. You ask, oh, how can we improve quality a little bit more? And you do the cycle again. You do the chain reaction. So um, that has to be at the forefront of your mind if you're going to have if you're going to effectively use the concept of agile in your software team. Now, there are three methods for increasing quality that over and above um, just have a really good track record with research. Capers Jones is probably the best and most complete publisher of research in the software industry. I had the pleasure of having him as a guest on my podcast, the Azure DevOps podcast, about a year ago, and I've read a number of his books. And so, if you haven't sampled his research or his books or his summaries, I highly encourage you to do that. But for quality, to get up to 98% what he calls defect removal efficiency, that's finding and fixing bugs before they go to your customer. His research suggests that a combination of um, three practices be combined to achieve that end, and that's static analysis and testing and formal inspections. Now, a deep dive into each of those is outside the scope of this particular webinar, but those we're going to touch on a few of those concepts. Now, um, the foundation of your successful implementation of Agile is rooted in those engineering practices that prioritize quality from the outset. The Agile transformation is reducing batch size, but everything that the Agile community has talked about over the last 20 years has been discussions and experiments and hypotheses on how a team might best succeed in furthering the reduction of batch size. It's not that, like, for instance, extreme programming had iteration planning, and then of course Scrum adopted that and called it sprint planning. And then there's retrospectives, maybe there's planning poker, and then there's a sprint review, and some teams have a sprint commitment. And I mean, there's so many ceremonies, but all of those are hypotheses about how might we continue to be successful in further reducing the batch size. If you don't make any changes and you just willy-nilly reduce the batch size, well, then your quality is going to suffer. You're going to start shipping more defects from what you were shipping. Everything's going to be chaos. And so, the goal is to reduce batch size, and that's a measure of success. But then the question is, okay, how? How are we going to equip our teams to effectively reduce batch size, to all the way down to making a single change and get that change quickly sent over to the customer and know that we haven't accidentally destabilized the software in any way. Okay. And so all the conversations have been about what practices should we adopt as a team? What skills does the team need? What kind of measurements do we need to have in place so that we can further decrease the batch size and then have a shorter cycle time and move faster without bad things happening? All right. So there's three things that I want to touch on here. And I want to kind of dive into testing a little bit more, but key among these practices is testing, and it has to be automated. Manual testing is just too slow. Manual testing ultimately in research is deemed to be too expensive and time consuming, and it leads to the widespread adoption of automated testing as a result, because it has to be that way. And then the practice of test-driven development, where developers write the automated tests simultaneously with the feature code, where you define a test and then you write the code to make the test happen, and you make asserts and then you factor the code. That is at the core of maintaining quality. And I'll demonstrate later that every type of effective test is essentially test-driven. It's essentially test first. There's some debates on test-driven development as it relates to unit tests, but when you look at it as a strategy, it'll make sense. And I'll cover that in a little bit. I want to just describe the static analysis that's effective briefly before I leave it. but it's another critical practice, and it identifies code issues without actually running the code. Um, your modern development environments and tools, they do have integrated static analysis built in, catching errors early in the development process. They just have to be turned on. And then there's other commercial tools as well that are effective. These tools, they not only improve code quality, but also enhance security by identifying potential vulnerabilities. And so SonarQube is a good one. Um, Independ is a good one. ReSharper has a good static analysis built in. And of course, the third, formal inspections, which we're not really going to talk about deeply here. It's a term that may seem out of place in the agile landscape, the word formal, but research has shown that formal inspections are highly effective in detecting defects before they escape the development environment. And these inspections, which they are formal because of the inclusion of checklists. They're checklist driven. They're integrated into, or the development one is best integrated into the pull request approval process. And that ensures a cost effective and low friction approach to maintaining quality, but achieving the formality that gains the quality that the research suggests is behind this. Okay. If you're not aware of the book Test Driven Development by Kent Beck, I encourage you to look it up and ask your teams about it. But let's look at the various types of tests just kind of applied across a Kanban board. And this is what a work tracking board generally looks like. We define the workstations across the top, or the stages, the statuses across the top. And of course, before the development column where the code is written, you have four key decisions. The conceptual definition is requirements. It's what are we trying to build? What's our objectives? And the next one, user experience design. It makes the design decisions about how it should look. Should I click a button? What should the behavior of the software be for this particular feature? After we define that, technical design is deciding whatever architectural elements need to be added, what design patterns, what libraries, in general, how are we going to implement this? And then decompose the feature into development tasks. Next is test design, where we decide what scope is in, what scope is out, how many scenarios is there a happy path through this new software feature? Are there some exception paths? But essentially, how many scenarios do we actually need to fully test this feature? Is it 2 scenarios, 3 scenarios, 4 scenarios? So this is the agile implementation of the old concept of a test plan, but it's very, very lightweight. It's just a set of bullet lists describing, what scenario we should run the software through to make sure that the feature has all the behaviors it needs. And if you think about it, if you think about the test first approach espoused by test driven development, if I'm going to just test the software manually, well, think about when I'm going to decide how the software should behave. I'm going to decide that in enough detail, probably starting in user experience design for a manual test. I'm deciding that there should be a button. I'm deciding that I should have to type something in a text box. I'm deciding that when I hit the button, if the text box is empty, that I have some type of validation error. Okay. And then some activities happen. And then once that new build is deployed to a manual test environment, well, then I can use my eyeballs and manually do the asserts or manually validate that this test, this requirement is satisfied. Okay. So the creation of tests is a design activity. In user experience design, I'm making design decisions, and then some activities happen, the software is built, that feature is built, and then I can make sure that that design was fulfilled properly. And so you come down in scope to a full system test or an end-to-end acceptance test. Before the code is written, I would decide that maybe for a login page, if they type the right username and password and hit the button, that it validates and forwards to some other screen of the system. That's one path through. The other path is wrong password. I should see a validation error. That's a second test. The third test is 3 wrong passwords in a row. Maybe I lock their account if that's a requirement. Well, that's a third test scenario. So I've made design decisions in the identification of 3 full system tests. Then of course the code has to be written, and then The code is actually the C sharp code and Selenium code perhaps is written for the automated full system test. And then the test is run, and then the assert statements can run, the validation. And then if the tests are green, we're good. Otherwise, we keep on working until the tests are green. So for full system tests, you can see that deciding what the test is a design activity. And then you do some implementation, and then running the test is your quality control activity. And so when you choose to use automated tests versus manual tests, you get the quality control activity for free the second run and third run and fourth run. And now every build, you just run these again, and you're doing quality control in that area over and over and over again. But the deciding what the test should be, that the test should exist, and what the steps of the test are, that's a design activity. Okay. But that strategically, it's not interesting to me to get into the developer debates about red green refactor and specifically, what line of code happens before another line of code. I'm talking strategy. Strategically deciding that some behavior should be there and what that behavior should be for that area of the software, that's a design activity. That's determining that a test should exist and what the test should be running and checking for. And then, of course, you write some code, and then running the test in your continuous integration. That's your quality control activity that just runs every test that has been built. And so for unit tests, for component level integration tests, within the development team, that time space between the design of the test and the first running of the test, well, that's very small because that's all on the developer's workstation. But if this test-driven strategy is not already in place in your team, then that would be something missing that you should ask about. Then for continuous integration, if your process should generally look like this. Okay, there's shades of gray, of course. It should generally look like this. And I'm going to go through the different questions that each part of the process answers. Again, I don't care what you call things, but you ought to be able to answer the questions that I'm highlighting. And if one is missing, that's a great conversation to have with your team. So before any code is written for a particular feature, again, we're talking about a batch size of 1 now. We're driving down to batch size of 1, and we're talking about the practices. We're talking about the engineering practices and processes around it that enable you to successfully drive your batch size down to 1 and thereby stream features through at an accelerating pace. So before code is written, we're going to just list out the test scenarios, list out the different ways that a new feature might have some behavior, the happy path, the exception paths. And that answers the question, hey, for this feature, what are the scenarios that are supported? And we're going to make that design decision. Okay. Then developer is going to write some code, and the developers use the private build, which, by the way, is the first stage of continuous integration. Continuous integration has been proven to be an absolutely essential engineering practice that enables shorter cycle times. And Agile is all about shorter cycle times. So your team should definitely be using continuous integration. We come across so many software teams who say that they're doing continuous integration, but come to find out they've only implemented one of the 3 stages of continuous integration, and nobody in the team has actually ever read the book that defined continuous integration in the first place. So make sure that your teams are aware of the definition of it. There was a book written in 2006. It's literally titled Continuous Integration. And there's 3 stages. The first stage is the commit stage on a developer's workstation, and the private build is the chief tool for that. The second stage is the integration stage, and the integration build is the chief stage of that, where all the code from multiple developers comes together. And then the third stage is the first deployment and startup, where a new build of the software is automatically deployed to some environment. The software is started up, and some basic checks, some smoke tests are run against it to make sure that software is generally stable and still working and didn't just flat out break. So those are the three stages of continuous integration that allow a team to cycle really, really quickly. So the private build answers the question for the individual developer: is my change ready to commit to source control? Is the code still stable, or did I just break something? And of course, if it's all good, then they commit to source control and push that forward. And then the integration build runs, mixing the code that an individual developer just changed with code from other teammates. And the integration build answers the question: is the code from all the developers mixed together? Is that code still stable, or did something destabilize it and break something? All right, we go forward. If all is good, we go forward. And then a automated deployment to our TDD environment, our test automation environment. That's the environment where no humans are allowed. A lot of development teams have a dev or a dev test environment where the individual developers do some manual testing, and that's great. There needs to be an environment specifically for the third stage of continuous integration where you run your first post deploy test. So we do our deployment and we start up the application, and that step answers the question: does this version still deploy and start up without throwing an error? Okay, because sometimes it happens and you want to check it really quickly so you can fix it quickly. All right, if that happens, you go forward after the first deployment. Then we're going to run our full system our full system acceptance tests, and those are automated tests. And those tests require a fully deployed instance of our entire software system, and they're going to run. And that answers the question. That stage answers the question: do all the test scenarios work properly? If we have a login screen and we've defined, three different pathways through the login screen, guess what? We're going to have three different full system tests that go through those scenarios with that login screen and make sure it actually works. And of course, if that's all good, then the developer from the branch for that feature, from the feature branch, can create a pull request, and then somebody on the team is going to decide whether or not to accept that pull request or not. And that's where your inspection comes into play. Just put a little checklist in that pull request, and that answers the question: does this group of changes in this pull request meet the team standard? And we found a lot of teams actually don't have a team standard. And the approving of a pull request is just kind of based on personalities or whatever it's based on. And so making a pull request a formal inspection, all it takes is just a little bulleted checklist. Hey, if I'm going to approve this pull request, I'm going to check this, I'm going to check this, I'm going to check this. However many, that's all it takes. Okay. Now, this is that's how all of these practices kind of fit together from an engineering flow perspective. But ultimately, to oversee a project, you need to measure success. So I want to talk a little bit about measuring success in agile projects. In these projects, success has to be determined by tracking metrics and establishing key performance indicators, KPIs. And your metrics need to encompass some aspects that include your throughput, quality, bug resolution time, the number of completed items, at a minimum. And the KPIs turn a metric, the KPIs layer onto the metric and create your view, your dashboard. A metric is just a number. A key performance indicator is the combination of a metric and a threshold. And that allows you to have a dashboard that has greens or yellows or reds. If your metric is how many features or how many development items were sent to production in a given day and week, well, you're just counting those. But the key performance indicator might be number of features delivered to production greater than 5 or greater than 10 or whatever it happens to be. And so in a given week, if it's less than 5, well, that KPI would be red. And if it's equal or greater than 5, that KPI would be green. So the KPI is a combination of a metric and a threshold for being good enough. And agile projects that prioritize high quality, well, they typically experience exponential acceleration in the pace of their development. Uh, I'll call it traditional or average projects where there's not a good focus on quality have really diminishing returns. But the agile projects with a quality focus, they stay fast paced. And the longer that they go in the project schedule, the team just gets faster and faster and faster and faster. Whereas without good quality practices, software teams generally slow down and stagnate. Um, the acceleration, it can lead to a fascinating dilemma where the software team's pace surpasses the business's ability to keep up. And that's an amazing place. Achieving that for a project is a fantastic turning point because you you kind of reach your terminal velocity and you decide how many developers you need to remove from the software team so that the software team only goes at the pace that whatever area of product management is being served. And so you want to track when your project gets to terminal velocity from whenever you start the project, because that's a big milestone. But let's analyze throughput and pace economically. This is a pie chart of developers' time. And there's some surveys that suggest that without intentional tuning, 30% of developers' time goes to meetings, 16% goes to just fragmented work like checking email or hopping from one thing to another, and then about 52% is focused work. And projects that have average quality end up spending half of that focused work time fixing bugs, and only half of that focused work time actually focused on new features. So without intentional optimization, the general forces kind of push down work time to 27%. That's pretty pitiful. It's pretty bad. But without intentional strategy to make it something different, this is kind of what it has ended up being in the industry. And by using defect removal techniques that are proven through research and using the right engineering practices and project management process, we can remove about 97% of the defects before they hit our users. But let's be conservative, by the way, for the sake of this analysis, and say that we only find and remove 90% before they get to the users. So with that increase in quality, then we can double the time that our developers are able to allocate to focused development and shrink the time on debugging. Again, we're not going to talk about how productive the focus time is or how good the developers are, but just want to talk about quality. And let's just skip through to the next step where we do actually take some action on meetings, because when we adopt Kanban and we adopt a single piece flow and drive down the batch size, well, that reduces even software related meetings, because the meetings that are dictated in Scrum, well, that takes up time. But if you go to a Kanban flow, single piece flow, those meetings kind of start going away. So now let's look at that focused development slice of the pie. That's huge. And again, regardless of the current productivity of an individual developer, just making capacity reallocations, we've more than doubled the output of our team from a throughput perspective, from just allocating our labor. And we still have the question of how to make the developers more effective through other practices, but that's for another time. The chasm between average software teams led by average leaders and great software teams that are led by great leaders is currently absolutely immense. But it doesn't take an immense amount of effort to cross that chasm. The knowledge, the practices, and the tools are known, and with your leadership, then it can happen for your team. Now, I talked about continuous integration a little bit. I want to leave you with a few resources. This is about the top 1/3 of our DevOps architecture poster that kind of places a lot of engineering practices and shows how the flow of a DevOps environment should look for your teams. And this is going to enable single piece flow, smaller batch sizes, and it's going to enable the the mindset of the Agile Manifesto. This is just a highly shrunken technical blueprint for that, and it's only the top third of the poster. You can't read the full poster, but if you would like a high resolution PDF copy of this that you can print out if you like, it's meant for a 2 foot by 3 foot poster. Then just send me an email or put something in the comments, and I'd be happy to get one sent to you. But as we close up, um, what we want is effective agile leadership, and effective agile leadership, it hinges on allocating capacity to new changes and features and changing the way the team works. And this ensures that the development team dedicates most of its efforts to value added work and minimizes unnecessary overhead. This approach maximizes your productivity. It minimizes your waste. It invokes the Deming chain reaction, and uh, it enhances the effectiveness of your agile projects. Um, Guiding a software department down the agile path with a focus on quality is your key to eliminating failed projects, or even underwhelming projects. This approach not only guarantees project success, but it also aligns the pace of the software team with the growing needs of your business. And if you are on a path to adopt Agile, or if your team has tried to adopt Agile, remember the key thing is reducing batch size. All other discussions are discussions about how might we best reduce batch size while increasing quality and decreasing cycle time. But all the debate is not whether or not we should reduce batch size. It's how should we best reduce batch size. And ClearMeasure can help guide you to be an effective Agile leader. So just contact us to learn more. And I thank you for your time. Hope you have a great day. So this will conclude the webinar, and I know lots of people have busy schedules. We will stick around for a few minutes if there are some people who want maybe some question and answer, submit some questions, or feel free to just send me an email, and we'd be happy to set up a consultation. So thank you very much, and I think I'm gonna answer some questions that are coming through. Just switch over to the Q&A. That was a question from early in there. Where can we get the .NET DevOps for Azure book? If you look at the chat, Melanie, who's assisting me with this, is going to put my email address in an email address and a link in the chat so that you can see where to get that book. All right, here's another question. My organization got a really sour taste for Agile. Is Agile falling out of favor? That's a good question. And the philosophy of that, or the marketing aspect or adoption, that's not interesting to me. What's more interesting to me is your software project succeeding and project success. Whether or not a certain buzzword, some people, implemented Agile poorly and had a failed project, because projects that are marked Agile, well, they don't have a 100% tracker. I think among Agile projects, I think the average is somewhere around 60% or 60 something percent success rate. So for projects that kind of identify themselves as using Agile, it's a little bit better on average, but I mean, 40 or 30 to 40% failure is still not good. And of course, we know from experience that people say that they've implemented a practice, but they really don't fully, or they don't get everyone trained. So that's not, calling a project Agile is not as interesting to me as you succeeding in delivering your software project. And the very first thing that you need to think about when delivering a software project is establishing a high level of quality right away, early in the project, and keeping it there. So then the question is, how do you establish initial quality And then secondarily, after achieving initial quality, which by the way, you have to measure in your scorecard, how do we keep it? And so your Kanban board is how you track your work flowing through. Every every column represents some type of workstation, and every column needs to have a little checklist of quality control. When when a software feature moves into a particular stage, a particular column, before starting work in that column, whoever's assigned to that column, that stage of work, needs to check that it's ready. So they need to have an entry checklist. That's a QC activity, and kick it back if it's not ready, because it doesn't help us at all if we miss out on some design decisions and then the developers write some code, there's some unanswered questions, and then based on the personality or experience of the developer, they make some assumptions and fill in some gaps that seem right to them, but then the code is written and now we find out that, well, we didn't want it to behave that way in the first place, and we kind of missed something doing initial analysis, or we missed a piece of needed behavior in the UI. Well, now we're downstream. Now we're several stages of work downstream from where the defect originated. So defects are more than just the code doesn't work right. There's all kinds of, you think of defect, just think of a problem. Think of something bad happened. Something happened that should not have happened, and now the user or the customer of the software is not going to get served properly. And so if we decide to put a feature in that's not helpful to the user, well, doesn't matter how the code is written, it's not going to work. That's a defect. Okay, so and um, there can be defects in every type of work. Okay, so defects are not just code bugs. But you start with establishing quality first, and after establishing quality, really quickly in the first 1, 2 features, establish your testing practices that are going to get quality and static analysis and formal inspections. Then get that burgeoning software application, very, very small, very little code, get it out to production or a to be production environment and start achieving stability. You want that software to be rock steady as it runs in the target environment. Because whether it's a bug in the code or whether the software is falling over in a production environment or having scalability problems or not doing what it's supposed to, or maybe it's running fine, but the way we configured it is generating much, much too high of a usage bill in the Azure cloud. Well, that's a problem too. So you want to achieve stability, and that's your focus. And then the productivity will come, because every ounce of thinking of your entire software team is aimed at keeping quality where it should be, keeping the stability of the software, and finishing the work that it sets out to. Problems with defects and problems with stability, they really occur because of unfinished work. We thought we were finished analyzing the requirements. We thought we were finished designing the UI behavior. We thought we were finished making some technical decisions about this feature. We thought we were finished identifying the necessary pathways through a particular feature when we identified scenarios. Or we thought we were finished with the code that would make all of these things go. But when we find a stability problem, or we find a defect, or what we're actually doing is we're finding that we're not done. There was some undone work. There was something that was missed. And we took credit for finishing a unit of work. Shouldn't have taken credit for it. It wasn't actually finished. And then we get trapped with the mistake of creating a list of bugs, a bug backlog. So now we have a feature backlog, a list of features that need to flow through the process. And now we have a list of bugs that need to flow through the process. Well, now how do we prioritize? Because now we have 2 lists of work instead of 1 list of work. Well, this list of bugs, this bug backlog, well, that's just a fabrication. That's not a real thing. We just accidentally took credit for finishing the feature. Well, the feature had a problem. Feature wasn't actually done. Now I get it. Sometimes we put something into production and then we find this nascent bug 6 months down the road, And that's the thing. But that's a much smaller list when those things happen than it is when I built a brand new feature and now people are trying to start using it, and there's a problem. Well, guess what? That feature wasn't finished. Now, the code might be completely finished for how we defined the feature. But if there was an additional bit of behavior that needed to be a part of the feature that we just didn't even analyze properly, well, that's where the problem is. We didn't finish our analysis. And so that can happen at any stage. But I don't care what you call it. I don't have there's no loyalty. There's no I love Agile versus there's no bandwagon. There's no soapbox. I want your software project to succeed. And this is how to make it succeed. Quality, stability, and then productivity. And then you keep it there and you grind, you keep it going. And by the way, your team is going to love it because they're going to win. Software teams love winning. They love going fast. Software teams don't like fixing problems. So hope that was a good answer. And I think I answered the next two questions kind of because they were related. So thank you all very, very much. I appreciate your time and y'all have a great day.